Dear students, in this video we will discuss forward, backward and central difference. Now here we are discussing the data types of with h as a constant value. So here we have data x0 plus h, x0 plus 2h, x0 plus nh, and y is equals to f of x is given to you, f of x0, f of x0 plus h, f x0 plus 2h, f of x0 plus nh. Or sometimes we are not using f, we are directly using y0, y1, y2. So this is just an alternate form of this type of data. That means here the distance between two consecutive x is fixed. So now what is forward difference? Forward difference, so here forward difference means difference between the next data and previous data. Just find out the difference between two consecutive values. This is called as the first forward difference. And since we denote forward difference with the help of delta, so delta f of x is equals to nothing but the next value of f, that means at f at x plus h, minus previous value f of x. So you can understood this by this graph. Here is x, here is x plus h next value after distance h, and the previous value is x minus h. Here the value of the function is f of x minus h, here the value is f of x, here the value is f of x plus h. So if we want to find out the first forward difference, then this is denoted by delta f of x, which is equals to, since we want to find out the difference at point x, that means here, so the next value is x plus h, and the value of the function at this point is f of x plus h. So this is equals to f of x plus h minus current value is f of x. So this is the first difference. So this is written here, delta f of x is equal to f of x plus h minus h. Here h is interval of differencing, here is the h, the interval of differencing. Similarly, just shift your value, current value at x plus h, then you need here x plus 2h, f of x plus 2h. So if you want to find out the first difference at point x plus h, then obviously this will be the next value, which is f of x plus 2h minus the current value, which is x plus h. So likewise you can find out the first difference at different x, at x plus h, x plus 2h and so on. So this is written here. Fine. Now if you want to find out the second order difference, that means del 2 f of x, then we can use this. So since our interest is to find out the second order difference, then del 2 f of x is equals to, this can be rewritten as delta f of x. But we know that what is delta f of x? Delta f of x is here, f of x plus h minus f of x. So just write down here f of x plus h minus f of x. Now apply delta operator here. So delta f of x plus h minus delta f of x. Now the value of this we have already evaluated in here. So delta f of x is f of x plus 2h minus f of x with the help of forward difference, minus again delta f of x is nothing but f of x plus h minus f of x. Simplify this, we get f of x plus 2h minus twice of f of x plus h plus f of x. We get this expression. Similarly, you can find out del 2 f of x plus h, which will be obviously x plus 3h minus twice of x plus 2h plus f of x plus h. and so on. So likewise we can find out the second order differences, so they are written here. Likewise we can find out the third order differences. So del 3 f of x can be written as del into del 2 f of x, but del 2 f of x we have already evaluated, which is this, so this is written here. Now apply this delta operator and then substitute the values, so we will get finally this expression. So that's why this is del 3 f of x is this f of x plus 3h minus 3 f x plus 2h plus 3 f of x plus h minus f of x. If you increase the value x by h, so again you can find out del 3 f of x plus h, which is f of x plus 4h minus this value. If you see the pattern actually, so actually your forward difference is following the binomial expansion. Binomial, here is the coefficient of f is 1, here is minus 2 and then 1. So actually we are having this type of pattern. If you will see, delta f is actually we get 1 minus 1. If you will see, the coefficient of f is 1, here the minus 1. In the second order difference, here the coefficients are 1, minus 2 and 1. If you want to find out del 3, then the coefficients are 1, minus 3 plus 3 minus 1 and so on. So this is the pattern, and this is evaluated with the help of NC3. Here NC1, NC2, NC3, NC3. So likewise, so they are following the binomial. You can easily understood this. So if you construct the table, then here is the table. The table is here. Table is shown here, forward difference table. Here we have taken 6 data points. The values are x0, x0 plus h, x0 plus 2h, x0 plus 3h, x0 plus 4h, x0 plus 5h. This is the values of x. Similarly, the corresponding values of f are y0, y1, y2, y3, y4, y5, or here is nothing but f of x0, f of y1, that means f of x0 plus h. This is y2 is nothing but f at x0 plus 2h. This is nothing but f at x0 plus 3h and so on. That means this x0, x0 plus h, x0 plus 2h, x0 plus 3h, x0 plus 4h, x0 plus 5h. These are the values of x. Based on this value, we have f of x0, f of x0 plus h, f of x0 plus 2h, f of x0 plus 3h, f of x0 plus 4h, f of x0 plus 5h. So these are already given to you. Now next column is the first difference, delta f. Delta f. So what is delta f? Next value minus current value. So write down here delta f and denoted by x0, because the first value is this, which is obviously equals to f of x0 plus h minus f of x0. Fine. Similarly, you can find out the next value in this column, x0 plus h, which is f of x0 plus 2h minus f of x0 plus h. Similarly, here delta f of x0 plus 2h is equals to f of x0 plus 3h minus f of x0 plus 2h and so on. So this is the first order differences. This is written here in the form of y. Similarly, you can find out the second order differences, del 2. Del 2 is nothing but this difference minus this difference. That means del 2f is not at x0 is nothing but delta of f of x0, which is nothing but delta f of x naught plus h minus f of x naught, which is delta f of x naught plus h minus delta f of x naught. Fine. Yes, and we have already evaluated these values here. This value we have already evaluated here. This value we have already, when you substitute these, so we get f of x naught plus 2h minus twice of f of plus f of x naught. This is the second order difference. Similarly, you can find out del t f of x naught plus h, del 2 f of x naught plus 2h, and so on. So this is second order difference. Similarly, third order difference, fourth order difference, five order difference, and after this we will not have any difference because we have a single value. Now you see the pattern of these differences. Here the initial index naught is constant in first. In each column you can see that the first value, the index is constant. Why not, why not, why not, why not, why not, why not? So that's why we are having this arrow. Similarly, second entries are having 1 1 1 1 1, so that's why arrow. So this is the forward difference, and arrow is in placed in this direction. Similarly, we will have backward difference, and we will discuss this in the next video. Thank you.